has changed with the new LiDAR base spec version 1.2. So there's the introduction of this 3D program. Again, I talked a little bit about this already, but it's kind of been an impetus for these new specifications. So quality levels are defined. This is kind of important to talk about. Two different quality levels. Quality level 1 and quality level 2 are basically acceptable accuracy levels for data for this 3D program. A lot of the data that I show you that exists in Wisconsin is not necessarily a QL2 level data set. It would fall under just a broad category called quality level 3. Still 2-foot contour level data, but the quality level 2 steps up the point density and vertical accuracy a little bit, and you actually do get to the point where 1-foot contours can be created from quality level 2 data. Again, it matches up with ASPRS accuracy levels. There's a 10 centimeter vertical accuracy level that matches up with QL2. That changed from what was a 9.25 centimeter to a 10, but you're basically talking about 0.3 of a foot vertically. The other thing that's new is there's vertical accuracy that's reported now in two different ways. You'll hear these terms NVA and VVA, non-vegetated areas and vegetated areas. It used to be with the FEMA spec, you would just take all of your vertical accuracy check data. So you take it from your bare land cover, you take it from your heavily wooded, you take it from your ag areas, and throw it all in the mix, and you'd have to meet the spec. But recognizing the difference, there's a difference between how accurate your LiDAR is under heavy conifer versus in a parking lot. So that this takes into account two different accuracy levels.
So obviously everybody knows these. It's your DEM, your DSM, and you have to process ground surface. On the right you have your DSM, which is your surface model, which contains things like buildings, trees, towers, basketball hoops, anything that's on the Earth's surface, cars, you name it. You can see all the little sheds and everything. In this instance, you don't see a lot of trees, and this is a neighborhood in Illinois, which, like Adam said, was full of ash trees, and they came in and chopped them all down. So this DSM was actually collected, or this data was actually collected post-tree removal.
All right, so we've talked about change detection. Mike had a slide on LiDAR and LiDAR. A lot of questions about how often should I refly my LiDAR. Well, one of it is what's your budget. So you don't have a budget for it. So I got 2010 LiDAR. A lot of counties in Wisconsin have that. Municipalities have access to that. Now I just flew Imagery, but I'm not ready to fly LiDAR for another 5 years. We talked about SGM technology earlier, right? Using your imagery in order to find your areas on the ground or building. So you build your surface from your LiDAR, you've got that. Build a surface from the imagery, and you still have another thing where I can look at change detection. So on the left you have your LiDAR surface, on the right you can see the 3D building that came out of this stereo imagery, how it was flowing, and you can see the change detection. You have your retention ponds that come up on the south side of the building. You can see a parking lot that was leveled at 2 different areas. You can see all that change. You can see the volume of change. If you're paying a contractor for moving a certain volume of material in order to flatten out and plane these things, you could actually then do another flight and figure out, did they actually move that volume that they billed me for, 150 metric tons at X amount of dollars? You can go back and look at the contractor and say, okay, I really did move that much, or you said you moved this much, you really moved this much. There's all these other things that you can really do with this change detection, again, from the data that you have to get to the solution that you need in the most efficient way possible.